Welcome to Runtime Atlas. Today we will take a quick look at the Kubernetes API server. Quick recap from the last session. HCD is Kubernetes reliable key value store. It does not run containers. It stores the desired and current state that the API server reads and writes. If HCD is where Kubernetes remembers state, the API server is the front door everyone must use to read or change that state. In this session, follow one request from kubectl into the cluster. The key mental model is simple. Clients do not directly edit nodes, pods, or etcd. Users, controllers, schedulers, kubelets, and automation tools communicate through the Kubernetes API server. The API server exposes the Kubernetes HTTP API. That API lets clients query and manipulate objects like pods, namespaces, config maps, services, and events. A pod is not just a thing running somewhere. It starts as an API object. A service, a deployment, a secret, and a node are API objects too. The API server is where those objects are accepted and served. When kubectl sends a request, it carries intent. Create this pod. List these services. Patch this deployment. The API server sees the verb, resource, namespace, user, and object body. A write request does not jump straight into storage. It moves through a pipeline, secure connection, authentication, authorization, admission, validation, and then persistence. First, the API server establishes a trusted connection. Then authentication asks, who is this request from? It might be a human user, a service account, or a component using credentials. After identity comes authorization. Kubernetes checks whether that identity is allowed to perform this verb on this resource. Can this user create pods here? Can this controller update this object? Admission happens after authorization. Admission controllers can inspect the object being created or changed. They can set defaults, enforce policy, or reject the request before it is stored. If the request passes the checks, the API server validates the object for that resource type. Then it writes the accepted state to the object store, which for Kubernetes is backed by etcd. Reads are simpler, but they still go through the same front door. When you list pods or get a service, the API server serves the current object state back to the client. Kubernetes components often watch the API server instead of constantly asking the same question. The scheduler watches for unscheduled pods. Controllers watch the objects they manage, then react when state changes. This is an important boundary. The scheduler does not directly write to etcd. It watches the API server, chooses a node for a pod, then sends the binding decision back through the API server. Controllers also use the API server as their feedback loop. They read desired state, compare it with observed state, and submit small changes back through the API when the cluster needs to move closer to the goal. On each worker node, kubelet watches for pods assigned to that node. It starts containers through the runtime, then reports pod and node status back through the API server. The API server is not the scheduler. It is not the controller manager. It is not the kubelet. Its job is to expose the API, guard the request path, serve objects, and persist accepted state. If the API server is unhealthy, the cluster can feel stuck. Existing containers may keep running on worker nodes, but new commands, watches, scheduling updates, and status changes can fail or become delayed. When API requests fail, warp the path in order. Can the client reach the server? Is the user authenticated? Is R back allowing the verb? Did admission rejected? Did validation fail? Is storage healthy? Here is the mental model. The API server is the guarded front door. etcd is the durable memory behind it. Components watch the API, react to changes, and send updates back through the same door.